In this video we're going to be looking at the issues that came out of the ACDC and plugs exam questions, so comparing the use of the term voltage compared to potential difference, the use of alternating current versus alternating potential difference, what the difference is and also what's causing what, why we need to specify that our pins and plugs are made of brass and not just saying they're made of metal. We need to look at what happens to a fuse when a current passes through, not just talking about when a fuse, the wire melts, but actually the use of a fuse as a resistor, just like other components of a circuit. We'll look at the two key terms, insulator and conductor, and then we will also look at why the earth wire is necessary to be connected to metal casings, such as in an oven, in order to protect us from getting electric shocks. Okay, so we're going to start off this video by looking at potential difference and why at GCSE we would refer to it as potential difference rather than voltage. Now, they are pretty much the same thing, potential difference and voltage. However, potential difference is the term that you will see being used, and so therefore is the term that you should use. And what our potential difference is actually telling us is the difference in potential between the positive and negative terminal of your battery. So there is a difference, a numerical difference between that positive and negative, which is your potential difference measured in volt. We also look at how our potential difference is our energy supplied per charge, and that's by our battery. When we look at components, and we'll look at this more next year, but say we have a bulb, we also have a potential difference across that component. So again, there's a difference in potential between those 2 points that we're measuring across that component. And using the term potential difference, it's giving us more about what our potential difference is compared to voltage, as our potential difference is our difference in potential across a component, but really it's also the energy per unit of charge. We then need to look at our alternating current versus alternating potential difference as terms. So this S on both of these is indicating that it's an alternating current, and that's because our potential difference is alternating between being positive and negative, and that's going to be changing the direction in which our electrons flow. So here, if I've got my negative terminal on this side, then my electrons are going to be moving in this direction, but that means that my current is moving in that direction. So remember, current conventionally is opposite to the electron flow, but remember that electrons are always going to be moving away from the negative terminal. And so here our negative terminal is here, so now my electron flow is moving in this direction, but my current is going to be moving in the opposite direction. So my alternating current means that my current changes direction, and that is due to an alternating potential difference. So it's our alternating potential difference which is causing this alternating current. but they are not the same thing, so we need to be careful about what term we're using. So when we're comparing AC and DC, we need to be talking about our current changing direction. Fuses, so we haven't looked at circuit symbols yet, but this is the circuit symbol for a fuse. Now this is quite appropriate actually in telling us what a fuse is, and that's because it's showing us that there is a wire running through that fuse. Now, as we learned last week, well, for a start, all components have some resistance, and as our electrons pass, they transfer energy to the metal wire, or to the metal ions in the wire. This causes the ions to have more kinetic energy as they vibrate more, but also it causes them to get warm. So our fuse and other components, they act as a resistor. And so what that means is as a current passes through, when we've got a flow of electrons, they're transferring energy, and so this causes the wire to get warm and to heat up. A lot of us were talking about what happens to a fuse when a high current is passed through. Now that's where it causes our wire will melt when a high current is passed through. However, before that it's acting as a resistor, so it's getting warm anyway. But if too high a current is passed through, that's what causes it to melt, and therefore our circuit to stop flowing. A lot of us were also talking about our fuse blowing. However, we need to be scientifically accurate here, talking about it's the wire is melting, and that causes your circuit to break. Because if the wire breaks, your current can't flow through that complete circuit. Thinking about the materials making up our plugs, so we have a plastic casing. We use copper wires, and then we've got a plastic cable, and then each of these pins are made of brass. So our copper wires, why we use copper, has a high conductivity, which means it allows those electrons to flow through without too much resistance. And they're also, the fact that they're able to be made into wires, that's because they're quite ductile, and our copper wires in particular are very flexible, which means that you can bend them a lot, which is why they're suitable in your cable. Whereas the pins, brass is very hard. It's a hard material, and you need a hard material for the plug. You don't want the pin to be moving in and out of place when you put it into a plug. You need a hard material that is not flexible, so that's why we use brass instead of copper. And this is also why we need to be specific that it is brass, because it's this particular property of brass which makes it suitable for the pin plug. It is also still a good conductor. It's not as good a conductor as copper, but it's still good enough, and it's the hardness of brass that we want for it to be used as a pin. In each of these cases we're talking about insulators, so they don't allow electricity to flow through them. So thinking about materials which are conductors and insulators, start off with conductors. So these have a high conductivity, and this is because the electrons are able to freely move inside the material. Now, our metals have a lot of delocalized electrons, which we're going to look at next year, but that's what makes them good conductors, is that their electrons that are delocalized are able to move freely in that material, and so they're able to conduct the electricity. Our insulators, however, they don't really contain free electrons, and so our current can't pass through as easily. So electrons not able to freely move, and so we don't conduct our electricity. So to simplify it down, we say insulators do not conduct electricity. They insulate, they prevent that electricity from flowing through, whereas our conductors allow current to flow through. And therefore conducts electricity. So this question is after why that earth wire is necessary to be connected to the metal case. So the questions are saying that if a fault makes the metal case live, the earth wire and fuse inside the plug prevent the mains cable from overheating and causing a fire. Explain how. So if our metal case becomes live, this means that the current will flow to the earth wire, as that earth connection to the metal case will allow that current to flow to the earth wire. As there is a large current flowing through, this will cause our fuse to, the wire in the fuse to melt, and therefore our circuit will stop flowing and it will no longer be able to be live. So the two key points there is that your current flows to the earth wire, and due to it being a large current, this causes our fuse, the wire in the fuse, to melt. So take a look at the feedback that I've given you in Microsoft Teams, and then choose at least one of these DARE activities to complete and submit your answer via Teams.